Welcome back. I'd like to continue our discussion from Chapter 6, Confidence Intervals. This time, however, we are going to be encountering a more realistic scenario where sigma, the population standard deviation, is unknown. And yet we are still trying to create a responsible interval within a particular level of confidence for this unbiased point estimator for a population mean in this case. We're still going to be adding and subtracting that margin of error, only this time the calculation of the margin of error is going to be different because we don't know as much as we did before. Remember, when n was greater than or equal to 30 and 6.1, we were able to use normal distribution techniques because we knew the central limit theorem applied. In this section, I draw your attention now to page 310 in the textbook, 310 in the textbook, where it indicates that in many real-life situations, pop standard deviation is unknown. So what do? We can't necessarily rely on normal distribution techniques because we don't know for a fact that that would be most applicable. So instead, we're going to use something called a t-distribution, a t-dist. Now, the t-distribution has some of the same characteristics of a normal distribution, but it's a bit more forgiving. First of all, you'll notice that there's a new calculation for what we call critical t-values. Looks an awful lot like what we've seen before, but this time we're using S, which is the sample standard deviation. You see, we can't use pop because we don't have pop standard deviation. It's unknown. So when we're doing the t-distribution problems, we have to work a little bit differently. Also, the margin of error still required, but now we're going to use this critical t-value times sample standard deviation divided by the square root of n. Again, it's a sampling distribution approach, but we cannot use pop standard deviation. We have to use sample standard deviation. There's a list of 7 items on page 310. I'd like for you to take a look at those. When we're talking about a t-distribution, number one, again, t-values calculated that way. There's a table in the back of the book. We also have calculator techniques for t-distribution, so we're happy for that. It'll say that there are properties such that mean, median, and mode are equal to 0. So again, much like a z-distribution, or a normal distribution where z equals 0 in the center, t will equal 0 in the center. That feels good. Oh, it's bell-shaped and it's symmetric about the mean. That's important, very much like the normal distribution. Oh, item number 3, total area under the curve still equaling 1. Sum of all probabilities of this continuous distribution still equaling 1. That hasn't changed. Item number 4, however, very important. The tails are thicker. The tails are thicker. We've talked about the fact that the normal distribution is asymptotic, that it's never going to come into contact with the horizontal axis because in theory there could be some minuscule probability as the x values are approaching infinity. So we never intersect. But in a t-distribution, we say that the tails are thicker, meaning greater probability can live there. And that's because we don't know as much about the data. We don't know sigma. We don't know the population standard deviation. This population could have greater variability than we think that it does. So because of that, we are allowing the t-distribution to rest a little bit higher. It takes a lot longer to settle out. If you look on the bottom then of page 310, you'll see that the t-distribution is considered a family of symmetric curves. And again, the more knowledge we have, knowledge is power, okay? And this is really a function of sample size. This is super important here because we're introducing something called degrees of freedom. And degrees of freedom are defined to be n minus 1, one less than the sample size. And the gist of the story is this: the larger the sample size, the higher the degrees of freedom. The higher the degrees of freedom, the closer the t-distribution is to the normal. So hopefully, again, intuitively, we understand that. So let me say it one more time. The degrees of freedom, which are a part of the t-dist calculation, are always one less than the sample size. So as n increases, the degrees of freedom increase. As the degrees of freedom increase, the curve looks more and more and more like the normal distribution. Ultimately, one would not be able to tell them apart. Okay, if you look in your textbook with me on page 311, we have an excerpt from the table that's in the appendix, table 5. You'll notice this time when we are using the table for calculation purposes that there's a new column called DF, degrees of freedom. So in the example number 1, at a 95% confidence, we're choosing the column for 95%, but notice, we have to use that first column as a line marker. If n is 15, then degrees of freedom are 14. The critical t value then that we choose to use in the error calculation comes directly from that table. You'll notice then underneath they've shaded in blue for us the 95% confidence area, utilizing the two t-scores, the plus and the minus. On the bottom of page 311, please take a look at it. When the degrees of freedom that you need are not in the table, use the closest that is less than the value that you need. Less than, don't go above. If you go above, then you're presuming that your distribution is more normal, which is not responsible. Better to have more thickness, if you will, in the tails. Better to have a greater margin of what? Error available to you. That way, you're more likely to hit the dartboard, aren't you? So be careful of that if your value does not appear directly. Over on 312 then, for calculation purposes, it's going to feel very, very much the same as 6.1. Only this time, again, the t-values for calculation purposes, the error calculation, the error margin of error calculation comes from a t-dist as opposed to the normal distribution. Now, aren't we lucky? Guess what we have? Well, we can construct these confidence intervals using our TI-84 calculators as well. Please go back into the calculator, hit your stat button. This time, however, under test, arrow all the way down to item number 8. Item number 8. So again, we're using the stat button. We're arrowing over to tests, but this time we're choosing item number 8, which is the t interval. Again, your calculator knows now that you don't have sigma. So when you enter to choose it, again, please go for the stats reference as opposed to the data. Do not choose the data because that would require you to put the raw data in, and you'd have to then find, and you can do that, you'd have to find the sample standard deviation on your own and so forth. But presuming that you know what the x bar value is, and that you know what the sample standard deviation is, and that you know that the sample size, and you know the C level, again, that confidence level, if you put this information in, out pops the interval for you. So a lot of this is going to be quite easy, assuming that you are interpreting the wording correctly. So how do I know what to use and when to use it? I found that in chapter 5, that was problematic for us. You know, I like to be a belt and suspenders kind of person, and I like to make sure that I'm doing the right thing at the right time. But several of you were using formulas and techniques at the wrong time, and some of you were just doing everything at once, just in case. We don't want to do that. On the top of 314, you'll see a bit of a flow chart, and it's basically directing your path. When sigma is known, and n is greater than or equal to 30, use techniques from 6.1 section. Normal distribution, z-scores, inverse norm, use the table. Memorize the 3 levels that are industry standards, 90, 95, and 99. However, if the population standard deviation is unknown, these are the problems that we're finding in 6.2, then the margin of error calculation comes from a critical t-score. This is a t-distribution value. Those values can be found from the table in the back of the book, or again, you're very welcome to load all of the pertinent information directly into the calculator and have the calculator generate the interval for you. Home assignment problems. 1 through 16, today the 25th, due this evening by 9 o'clock, PDF uploaded to the assignment. Tomorrow then, the 26th, 17 to 35 odd. Again, these are more of the applications type problems. Of course, check your answers, but I expect to see more than just the answers in your PDF. So this ends our discussion of 6.2.